Okay, question 13. I'll start this one off with the Qiskit API and how they describe it. Qiskit, the API describes it as, however, when you try to look up what depth is for Qiskit, however, so the depth of a quantum circuit has a mathematical definition as the longest path in a directed a cyclic cycle, something complicated, right? Then the Qiskit API themselves say, however, such a definition is a bit hard to grasp, even for experts. Okay, so we actually filmed this before, and I was like, I wish I could find a more satisfactory way to describe, how to solve this problem. But even the Qiskit API is like, this is kind of hard. So we'll go into that in a second. But for the actual, the relevant stuff for the exam, okay, so I guess breaking down the problem. Given the following code, what is the depth of the circuit? So here, what do we have? QC equals quantum circuit 2, 2. So, from past problems, we already know this, but just refreshing. They set up this thing called QC, right? They use the quantum circuit method, and the 2, 2 means they're setting it up with 2 qubits and 2 classical bits. So they're setting up a quantum circuit with 2 qubits and 2 classical bits. What is the depth of the circuit? So what do we have here? So we apply a Hadamard gate on the 0th qubit. Again, remembering this kind of coding stuff. Coders start counting from number 0 instead of 1, just how coding is. So they set up a Hadamard gate on the 0th qubit. They set up a barrier on the 0th qubit. They apply a controlled NOT gate with the 0th qubit being the control and the first qubit being the target bit. And they apply a barrier across these two. Okay, so what is the depth of the circuit? It's not as simple as counting the commands they entered. On the right, you'll see barriers and snapshots do not count towards circuit depth. So what I'm going to do here is I'm going to go to the external input and show you guys where it says that in Qiskit. Again, we're also looking for ways to answer our questions when we have them. So I'm going to type in Qiskit. Let's see here what the command is, the depth. So I already have it, but Qiskit depth, Qiskit API depth, and we'll see what kind of things we get. So we'll open the first one, open some links, and part of what we're doing here is we're trying to learn how to navigate this API, which is the API is like what we're able to do with the command. APIs are very important in coding. If you look up the Spotify API, you'll be able to see the commands you're able to use using Spotify, like the internal ones. So very important stuff to know if you want to do something with a certain software. Okay, quantum circuit.depth. Let's see here. So it's a matter of learning how to kind of parse through the stuff that you're given. Not everything's going to be incredibly useful, but what you want to be able to do is recognize those gold nuggets when you run into them. So quantum circuit.depth, let's see here. Return circuit depth, length of critical path. Of course, this is on Qiskit. The exam itself is in person. You won't be able to use this this command, which is worth factoring in for how much time we spend on it. Filter to function out some instructions. Let's see here. By default, filters out directives such as barrier or snapshot. So again, Qiskit telling us barrier or snapshot does not count towards circuit depth. If you see that, don't count it. Again, in the example, we see barrier twice, but we'll go back to that in a second. Again, just going to the Qiskit API. Depth, let's see here, calculate the depth. And again, not everything you find is going to be like what you're looking for. Return circuit depth. This does not include the compiler or simulator directives such as barrier or snapshot. So again, we see that being the solution. So again, going to the Qiskit textbook, this GIF is what I tried showing last time, and I wish that I could put it into words how, but leaning on the fact that even Qiskit was it's hard for the experts. All I can really say is study this GIF. Even they themselves, they say rotate the circuit and let the gates fall as far as possible. So they start with the original, and then they rotate it, and they describe it like Tetris. So while it plays, I'll read their description real quick. A particularly important circuit property is known as the circuit depth. The depth of a quantum circuit is the measure of how many layers of quantum gates executed in parallel it takes to complete the computation defined by the circuit. Because quantum gates take time to implement, the depth of a circuit roughly corresponds to the amount of time it takes to computer to execute the circuit. Again, notice I'm talking about like roughly, like, you know, this stuff is still, you know, again, so cutting edge that it's still in development. You might run across terms that say they're deprecated because they've been updated. So it's a living thing. So there's going to be changed and updated in the future. You just got to keep up with it. Thus, the depth of a circuit is one important quantity used to measure if a quantum circuit can be run on a device. So if you're looking for the very technical definition of what depth is, the depth of a quantum circuit has a mathematical definition as the longest path in a directed acyclic graph, a DAG. We won't go into what that is here because it's not important to the certification, but that is what circuit depth is by definition, which is, you know, nothing. However, such a definition is a bit hard to grasp, even for experts. Fortunately, the depth of a circuit can be easily understood by anyone familiar with playing Tetris. Let's see how to compute this graphically. So we have this GIF here, and we want to study this to learn how things are going. Please notice that there's a Hadamard gate that falls past the CNOT almost. You would think it would stack, but there's small details like this. Please try to notice this X gate. It falls. You know, you would think it would stack. So please try to spend some time on this, because I got the question myself wrong on the exam. So if we look at the solutions they go on the left, the instructions, they say rotate the circuit and let the gates fall as far as possible. The gates fall into layers, and then the depth of the circuit is the number of layers. I wish I could give a more satisfactory answer, but I have to just resort to the same thing Kiske was like, and it says, you know, is a tough thing even for experts to understand. So this GIF, please study it. Notice how these CNOTs stack, not stack, but like, you know, fall into the same row. Notice how this X fell into the same row, and notice that these stacked on top of this. CNOTs are part of the pattern, and things that are controlled gates or gates that depend on other gates also play a role in how they separate into layers. Notice the ones that are related, the controlled gates, they kind of create their own layers, right? They don't fall through. Okay, so finally going back to the question on the paper. Given the following code, what is the depth of the circuit? This barrier does not count, and this barrier does not count. So because those barriers and snapshots do not count toward the circuit depth, the answer is